In this section, section 4.2, we're solving equations using multiplication and division. All right, does anybody remember what two operations were in 4.1? Adding and subtracting. So the reason they're split up this way is because addition and subtraction are inverses of each other, and multiplication and division are inverses of each other, meaning whatever operation is connected to the variable, the inverse or the opposite is what we need to do to solve for the variable. You'll see more of that in a minute. But multiplication and division is where we're focusing today. All right, so there's a couple terms or just definitions that you need to know. You should already have this written down. So let's just read through it. Equations have how many solutions? One. There is only one value that will make the equation true. I put a pretty simple equation in here. Would you agree? That's a pretty simple equation. All right. Would you also agree that you could pretty much solve that mental math? 5 times what equals 15? Just tell me. 3. Okay, so you say, Miss Kinder, I can solve that easily in my head. Why in the world do I need to show my work? My answer to that is simple, and that is that it's just as important to learn the process as it is to come up with the answer. Because I promise, as you move into Algebra 1 and Algebra 2, it is near impossible, if not impossible, to do these using mental math. You understand inverse operations, then you're good to go, okay? An inverse operation says, what operation is connected to my variable? 5 and x together mean what? Multiplication. So in order to get the 5 away from the x, or essentially cancel it out, I need to do the opposite of that operation. What's the opposite of multiplication? Division. So I am going to divide. Does everybody agree that 5 divided by 5 would cancel down to 1? Yeah. Everybody agree? So now x is by itself. You see what we did there? All right? But we can't just erase the 5 like, I don't want you there. You erase, all right? And then we just have an x. There has to be something that we're following math rules, okay, to move it to the other side. And that's inverse operations. Whatever I do to one side, I have to do the same thing to the other. And that's where we get the x equals 3 solution. All right, so again, showing the steps is very important. I'm not going to give you credit on your homework assignment if you don't show the work. Okay, I have to see the work. If all you have is an answer, I won't give you credit. I'm going to ask you to redo it for half credit. All right, now to check. You're going to do the same thing you did in 4.1. You're going to plug it back into the original problem. 5 times 3 equals 15. And is that true? Yes. So you're going to show that it's true by checking it out. And you must check on your homework. On the quiz and test, it's optional, but it's a great idea because that's a really good way for you to know you have not made any simple mistakes. All right, hold your questions just a sec. Okay, so what am I doing here? I'm getting the variable by itself on one side of the equation. That's my whole goal for solving. Whether it's addition, subtraction, multiplication, division. That's my ultimate goal, is to get the variable by itself. And then we need to talk about reciprocals. What is a reciprocal? Does anybody remember? Okay, duh, yeah. Flip fraction, I wrote that down. Yes. So what would be the reciprocal of 3/5? 5/3. 5/3. But here's what you need to understand. This does not cancel down to 0. It cancels down to 1. There's a big difference between 1x and 0x. Is 0x even a term? No, that would mean it completely cancels. So it's important for us to realize when I multiply by the reciprocal, it's reducing down to 1. And we know that 1 is understood and we don't necessarily have to write it, okay? 1x or just x. Okay, so that's where we're going. Hold on, let me pause it real quick and answer a few questions. All right, example 1, okay? No, that's not the one. All right, in example 1, what do I see here that is connected to my variable? Would that be division or multiplication connected to my variable?
Division.
That's definitely division. It's a fraction. Fraction is division, okay? There's no way around it. That's what it is. All right, so because division is connected to my variable, I need to do the opposite operation in order to get the x by itself. Again, that's my ultimate goal. So whatever number is connected to my variable, that's what I multiply both sides by. Okay, so in order to get 3 to cancel out, I would multiply it by 3 over 1. All right, so the 3's reduce, okay, and I just have x by itself. But whatever I do to one side, what's my rule? Do to the other side. So now I have to multiply the other side by 3. And what's negative 6 times 3?
Negative 18.
Negative 18. All right, so I am pretty confident that this is my answer. But how can I be sure? How can I be positive? Okay, I need to check it. How do I check it?
You rewrite it and put the x where
Yes, very good. So I need to now plug it back in for x. And I get negative 18 divided by 3 is negative 6. Okay? And is it true that negative 6 equals negative 6? Yeah. So again, on your homework, I need to see a checked or a boxed answer and a boxed checked answer. I need to see both on your homework. It calls for checking, and you need to make sure that you check. On the quiz and test, it's optional, but it's a great idea. All right, so based on how we just solved the first one, I want you to solve and check the second one. You say, I can do it in my head, and that's great, but you still need to show the steps. Okay, go ahead and do that. All right, so did you multiply or divide? Multiply by what?
5.
Multiply both sides by 5 over 1. Again, 5 over 1 times essentially 1 over 5 gets it to reduce down. And now all I have left is the x. That was my goal, but whatever I do to one side, I have to do to the other side. So that's why x equals 10. I'm not done there, though. I need to double check that my answer is correct. And guys, on your quiz and test, just do that in your calculator. You don't have to show any work. Okay, but that's a simple step that you can use your calculator for just to double check your answer. On your homework, you need to show the steps. All right, so 10 divided by 5, is it true that that's 2?
Yes.
2 equals 2, and it checks out. All right, now if you want to show that on quiz and test, you can. All right, so again, make sure you box your answer and your checked answer. Any questions so far? So when division is connected to the variable, I multiply to get the variable by itself. So what do we see on the next one? All right, we see no fractions, right? We see no fractions. Now, what else do we notice about this first equation? I'm not a huge fan of the fact that they made this the first one. You don't see a number in front of the variable. So if there's no number there, what number is actually there? No. A1, okay? So pay attention to this, guys. It's important that we understand that because our variable cannot be negative. If it had just said a equals negative 24, there's nothing to solve. But because it's negative a, my variable cannot be negative in my answer. So it is simply a matter of now recognizing there's a 1 there. And now, again, I wish that we had a different one to start with, but you remember that a number and a variable connected together with no other sign means what operation? Multiplication. So what is the inverse of multiplication? Division. So I need to divide again by whatever number is connected to my variable. So on the last slide, okay, it was multiply by whatever number. Now I divide. So what number is connected to my variable? Negative 1. So if it's negative, you got to take it with you. So A equals positive 24. All right, that's my answer. Now when I plug it in, the negative is already there. So is it true that negative 24 equals negative 24? Yep. Okay. It's not a trick question. All right. I know it's kind of goofy because there was no number there in the original problem. All right. What do you notice about the second problem here? Hold on, there is a variable. Where is the variable? Yeah, the variable comes after the equal sign. How many of you would say that you would kind of view this equation as being written backwards? Would anybody kind of say that it's written backwards? Because usually the x comes first. If you want, you can rewrite it with the x coming first, as long as negative 4.5x is still on one side and 18 is still on the other. I would not recommend that going forward in the long term because switching it around is not necessary, and I've seen too many times people people switch it around and write it down wrong. Okay? But I just wanted to point that out, that it is the same equation, okay? I'm going to leave it in its original format, but you can switch it around. You can, all right? So what operation is connected to my variable? That's the question I always want to ask. What is it, guys? Multiplication. And can I tell you this? It will become habit for you to just look at it and you know you're supposed to divide, okay? And that's okay, but you need to understand the why. The why is it's multiplication connecting, so that's why I divide it by what is connected to x. What value is connected to the x? What number is connected to the x, guys? Negative 4.5. Okay? All right, so let's think, okay? That's okay. All right, but here's what I get on this question. I get kids dividing by 18 all the time. And why is that? Because they have in their mind, I divide by the first number. All right, and they don't understand that I'm actually dividing by whatever's connected to x. It doesn't matter where the x is. If it comes first or second, it doesn't matter. Whatever's connected to x, that's what I divide by. All right, so I divide by the negative 4.5. If I don't divide by the negative, I'm leaving the negative with the x. That's pointless. Okay, so if it's negative, I have to bring it with me to the other side. What is 18 divided by negative 4.5? Negative what?
4.
Negative 4. How can I check it?
Multiply.
Yep, plug it back in. 18 equals negative 4.5 times negative 4. And is it true that a negative times a negative is a positive? Yep, 2 negatives. Okay, so it does check out, even the signs. All right, so the sign is important. Let's say you accidentally put positive 4 as your answer. Well, when you check it, you should realize you got it wrong because your signs and your answer won't match up. All right, so the signs are really important. Checking definitely helps you make sure you got it right. Okay? Yes. Example 2 now involves reciprocals because now what do we see connected to x? A fraction. Now, I want you to hear me on this, guys. This is a fraction being multiplied by a variable. Would you agree? A fraction connected to the x. I am essentially multiplying the fraction by the variable. If it's multiplication, what am I supposed to do? I'm supposed to divide by whatever's connected, to divide by 4/5. But guys, what happens when you divide fractions? KFC, right? Flip the operation, or flip the fraction, and then you multiply. So that's why we just jumped straight to multiply by the reciprocal. But guys, you need to understand, essentially what I'm doing is I'm dividing by that fraction. All right, does that make sense? So if I'm dividing 4/5 divided by 4/5, all right, because what I'm supposed to do here is divide by 4/5 to get the variable by itself. But when that happens, when I divide fractions, I have to KFC 4/5 now times 5/4. So that's why I just understand anytime a fraction is being multiplied by the variable, instead of going through all this work up here, I just multiply by the reciprocal. I just know. In order to get 4/5 to cancel, I need to multiply it by 5/4. Okay, to get it to cancel down to 1. All right, that's my goal, to get it to cancel down to 1 and get x by itself. Whatever I do to one side, I do to the other. Negative 8 times 5/4. All right. Well, negative 8 is technically my numerator or denominator. Which one? Negative 8 is technically, no, it's negative 8 over 1. It's the numerator. Okay. What's negative 8 times 5? Negative 40. What's negative 40 divided by 4? Negative 10. We're not sleeping, are we? Wake up. Okay. So it's negative 10. Guys, you can use your calculator. It's right there next to you. All right. If you want to use your calculators, you've already proven that you can multiply fractions. That's fine. You don't have to show any work here except what you're multiplying. So you can jump straight to negative 10. That's fine. Okay. How can I be sure? Plug it back in. What's 4/5 times negative 10? Does it equal negative 8? Put it in your calculator to be sure. Don't just say, oh yeah, for sure, negative 8 equals negative 8. That defeats the point of checking. Okay? You do need to be sure, and yes, it does. It does. All right, I want you to go ahead and multiply or solve for z on the second one. We've got to get a fraction to cancel out, but now my fraction's negative. Okay, so we can't ignore that. We can't leave the negative with the z. So someone raise your hand. What did you multiply by to get z by itself? Okay, how are we going to get negative 3 over 2 to cancel down to 1? I'm afraid. Okay, it's okay. It's all right. Zachary, what are you going to multiply by? Negative 2 over 3. Do you agree that now these are going to cancel and these are going to cancel? Yeah. And now z is by itself. How many multiplied by negative 2 over 3? Did you guys get to that step? Raise your hand if you multiplied. You might just be finishing up right now. Okay, so now what's negative 6 times negative 2 over 3?
4.
Positive 4. Negative 6 times negative 2 is positive 12. Divided by 3 is positive 4. How can I be sure? Check it. Plug it back in. So negative 3 over 2 times 4 equals negative 6. Okay, is that true?
Yes.
So show me that it checks out and box it in. All right, who got that right? Z equals 4? Z equals 4, raise your hand if you got it right. Okay, if you got it wrong, do you understand what you missed? Okay, are you seeing your mistakes? So it's just as important to see where you're making mistakes as it is, getting it right. We're still very much in the learning process. Okay, let's solve one more of these. Okay, we're just going to do the first one. Raise your hand when you have the answer. All right, I want to walk around and check. All right, what do I multiply both sides by? Negative 5 over 8, both sides. Okay, negative 5 over 8. And b equals negative 25 over 8. Or negative 3.125. Okay, either answer will be fine. You just plug in either the fraction or the decimal to check it. All right, last example. Okay, example 3, modeling real life. Okay, so I'm just going to tell you, all right, so we don't have to turn in our books, we're running out of time, that at midnight, the temperature is 56 degrees Fahrenheit. Okay, it decreases 4.5 degrees each hour. When will the temperature be 29 degrees Fahrenheit? All right, so what information do you think is important in this problem?
The time.
Aramis? Okay, what time it is, midnight? What other information do you think is important, Miles?
How much it decreases per hour?
Okay, 4.5 degrees per hour, definitely going to be important, okay? And they're asking me what? What is my answer going to be? When, specifically what time, will the temperature be 29 degrees Fahrenheit? Okay, so here's what I need to figure out. I know how much it's dropping per hour. Do I know how much it needs to drop total? Hold on.
Yes. Yeah.
I know that it's 56 degrees now. What is the temperature? What is my, you could call it my final temperature. What do I want my final temperature to be? 29. So is there a way I can figure out how much it needs to drop?
Yes.
Not divide. Subtract. 56 minus 29 is going to show me how many degrees total it's going to drop. That's going to be important. Yes, what's 56 minus 29?
27.
All right, 27. Okay, so that's how much it's going to drop total. All right, so total degrees dropped is 27. And how much is it dropping per hour? 4.5 degrees per hour. But I don't know how many hours it's going to take to drop the full 27 degrees. So what am I going to do to both sides? It's important to show your work. You have a problem just like this on your homework. All right, what am I going to do to both sides, guys?
Divided by 5.
No, divided by negative 4.5. Both sides. How many hours is it going to be, guys? 6 hours. but that is not my answer.
6.
Don't shout it out. Go back now and read the question, and you write down what time it's going to be. Okay? When will the temperature be 29 degrees Fahrenheit? When? Isaiah?
Where do you get 56?
It's from your book, dude. It's from your book. All right. I just said I was going to write it down so we didn't have to look it up in our book because we're running out of time. What time is it going to be, Kyle?
6 o'clock.
Okay, don't pack up quite yet, guys. It's going to be 6 a.m. Okay, 6 a.m. because I know it's 6 hours after midnight. Is it okay if I do one of your homework problems with you?
Yes.
All right, so we ran out of time, so I need to help you set up number 32 in your homework. Okay? Number 32 in your homework says the quotient. What operation is quotient? Division. And you write it in the order. Quotient of a number and negative 1.5 is 21. Okay? So we're simply translating a phrase into an equation. This looks to me like a pretty decent bonus question, all right? We didn't have a ton of time to spend on it in class, but we are figuring out what operation connects to the variable, and now we can solve. So on number 32, all you need to do now is solve the equation, all right? And that's everything you need to know for section 4.2.